Good morning, everybody. Well, it's almost afternoon, so I guess I'll just say, hey, everybody. Welcome back to my channel. Getting close to deer season down here in North Louisiana, or Louisiana, or the South. So probably won't have much more time to mess with anything here for too long. But I did decide on this Allied Radio Corporation Knight, I think it's a KM20 is the actual number of this thing. A nice viewer gave me that information. Thank you. I forgot what your name was, but thank you. But anyway, I'm going to go ahead and start taking the circuit boards out, marking everything. And go ahead and clean those. I'm going to clean the chassis. I'm going to check the electrolytic capacitors, which they could be good, but I don't think so. I think one of them's got a lot of leakage in it, but I might be wrong. And I'm going to clean it up, and I've been looking for a transformer for this thing, and the closest thing that I found is a Hammond universal output transformer for push-pull for 20 watts. I've never been good at figuring out exactly what the plate resistance is, or should the exact transformer should be on this, but I did look on the tube charts, and it's showing somewhere around 7,000 ohms, I think, impedance. So anyway, I'm thinking about if I can find one. They're back ordered. If I can find a universal output transformer, I'm probably just going to buy that and put in there. It was $50. Who knows? But anyway, when I find one, I'll put it in here and we can finish this up. But in the meantime, I'm going to pull these circuit boards out and make some diagrams and stuff of how all this stuff comes loose. Clean them up, check all the components on them, and check the electrolytic capacitors on them. And be that, you know, one step closer to getting this thing going. It could have its uses in my shop here, so but that's another video. Anyway, I'm going to shut you back off. I'm going to pull the amplifier space splitter board off and go ahead and set it aside, and then I'll pull the, I guess, preamp mixer board off and do the same thing with that, and then we'll start checking the capacitors, and we'll just go from there. Anyway, I'll bring you back when I get the amplifier face splitter board off. Back in a minute. Okay, I'm recording. Yes, I am. Okay, I've got the circuit board out of the amplifier board, which is right here. This is where the two 6973s go. The 12AX7 goes here, and the EF86 goes here. Here is the wiring right here. There's a ground going here. Let's see, and then here is a shielded audio cable going down here. Goes straight to the, is it going? Yeah, this is the audio input right here, coming from the volume control, center of the volume control right here. And then this right here is all your voltages right here. Your filaments in here, which is the red and black, if you can see that. So there's red and black is your filaments, and then you got something here, I don't know what that is. I'm not sure if that's a splice or it's a component in there, I don't know. Let's see, and then you got your H, K, whatever this mess is. Those appear to be grounds. So the brown and green is a ground. H, don't know. Anyway, I'm going to write all this stuff down, make pictures. I'll make pictures of it, and I'll make notes of it in a notepad, and then I'll just go ahead and unsolder these, and this board will be free. Zoom you out just a skosh. Get a pointer. Chinese chopstick pointer. Let's see what we got on here. We got 1, 2, 3, 4, 5, 6 large disc capacitors. This is a 0.02, 0.02, 0.02. These seem to be all 0.02s. We have a smaller little disc capacitor here. I can't read the value. We got several resistors. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, possibly 13, 14, approximately 15 half-watt Allen Bradley style resistors, carbon resistors. Then we got looks like a 0.47 ohm resistor here, if I remember right. That might be, yeah, can't remember. Anyway, that's looks like a 1 watt. Don't know. I think that's probably the cathode resistor, if I had to guess. And then one little tubular capacitor right here, and I bet you that thing ain't good. And the rest is the tube sockets, which are board mounted, of course, and that's about it to this thing. So let me unhook, make my notes, make my pictures, and unhook all this stuff, and we'll get it aside, and then we'll tackle this preamp mixer board next. So bring you back. Okay, I have the amplifier board out. Really not much to it. Really wasn't nothing big deal to it. Uh-oh, dropped my pointer. Getting old and clumsy. Let's see if I can. Anyway, you see a lot of rosin marks around here. That just tells you that these are where the output tubes were. And gets really hot there, and I think these things were not running correctly. But I'm going to clean this all off, reflow the solder on it, and that should be good. And I'm going to check all the components on this board. And then move on. But that's the amplifier board right there. No big deal. Well, this is the input selector / mixer board. That's what I'm going to call it. Zoom you out a little bit. This board right here has a long 12AX7 tube in here. Then it's got the function switch here for all your different inputs. And that is a little bugger. It had a little more wires in it than I anticipated. But we're going to get it out. But I just wanted to show you that first, so I will bring you back. Oh man, backache today. Oh, we did it yesterday, cleaning the hunting lease up. But anyway, I have the, I guess we'll call it the input board. Basically, all the inputs come through this gang switch right here. Really not much to it either, other than we got a handful of resistors, as you can may or may not see. Excuse me, a couple little black molded paper caps. Yay! And oh yeah, here's this 12AX7 I didn't mention in the last video, but this is it right here. I haven't even pulled it out yet or tested it or anything, but it will come out here shortly. But that's the input board. It's got a couple of Sprague something others on there. Don't know what the value is. Find out real quick. Might surprise you though when I test this thing that it might actually be good. Who knows? But I ain't leaving them in there. No sir. I'm going to all this trouble. I sure ain't leaving them in there. Appears to be a 0.1 microfarad at 200 volts. This one just happens to be C3. But I do have a question. And I hadn't really come up with hadn't really figured out what to do about it. But on this cadmium stuff, you can see it like on the front of this gain switch here. This is cadmium plating, and it's yellow, greenish yellow. Kind of looks like pollen. What is the best way to clean this stuff safely? How do you clean it? It does weird things when you put it in rust cleaner or resolver. It does weird stuff. How do you clean cadmium to get rid of this yellow? I've never quite figured that out. So far the methods that I've tried haven't worked. Yes, I have not been on Google and Googled it. But since this is a video that shares how I do things, and there should be other knowledgeable people on here, it looks like there is. How do you get rid of that yellowish stain to make this look decent? I don't know the answer to that. I have screws that's got that on it, various things. I don't know how to get rid of it. So if y'all could tell me how, I would appreciate it. So, okay, here's the chassis. Kind of gutted, getting her down. There's some more of that cadmium. Sorry about that. There's some more of that cadmium on the front of the switch here, on these controls right here. Yeah, even the light, the pilot light, if you can see it. All of that kind of stuff. All over the inside. You can see it. I don't know what to do about it. Somebody help me out in that department. I would be most appreciative. Alright, I think I'm going to pull the output transformer next. I think that's what I'm going to do. And I'm going to go ahead and pull the output transformer because I intend to totally strip and clean this chassis and rebuild it. Yeah. So, I'll bring you back. Alright, pull the transformer. There she blows. All this many splendored glory. Appears to be intact. I believe I have no reason to believe that there's anything wrong with this transformer. Other than it's going to need a little bit of a cleaning, a little bit of spray paint. There are some numbers stamped on it, 101317, and then below that is 1005216. One's a part number and one's a code maybe? I don't know. Alright. Chassis is getting bare. I didn't know I was going to go down this rabbit hole. But I'm going to restore this thing back as good as I can make it, if I can get the parts, on however long that takes. You know how this global supply chain disruption is really getting out of hand, to say the least. So now that I got all that, I guess my next step is not sure I'm going to clean this. Aluminum not to be hard to clean, so I'll probably just clean it. Might just manually clean it. I just got to be careful of those controls. But I might just gut this thing, take it completely apart. I mean, just completely, just take it out. start over, clean everything, clean the controls, everything, get them all shiny as I possibly can. I don't know, a lot of work, but you know how this goes. I'll tell you one thing and I do another. So anyway, let me get back to it. Alright, boys and girls. Continuing with the gutting of this Allied Radio Nite amplifier, 18 water. Anyway, I managed to get one of the electrolytic capacitors out of the thing. It's a really slick looking capacitor. It didn't tell me who makes this thing. It's a little different than what I'm used to. One thing is the way it's made and molded inside there, different than normal capacitor electrolytic can caps that I'm used to seeing. I'm not really sure who makes this thing. It almost looks like it's Japanese. I don't believe that, but anyway, I digress. So what I want to do now, leave you guys a little bit. I'll put it on my capacitor tester. Alright. Y'all, people that watch my channel know what I've got here. It's my free, to me, Syncor LC103 capacitor and analyzer, and capacitor and inductor analyzer. It's a high dollar capacitor and inductor tester is what it is, and it was given to me free, and I just can't get over that. So anyway, what I'm going to do is I'm going to set this up for aluminum electrolytics, and we're going to calibrate the leads, even though we don't really need to for this size capacitor. Alright, now we short the leads together, press short. Done. Now this capacitor is a 4-section capacitor. It's got, looks like 3 30 microfarads, or as I like to call it, microfarads. 30 microfarads. It has 3 of those at one of this is 500, 450, 350, and then there's a 20 microfarad at 25. So, wow. So let's set the machine up for 30 microfarad, 500 volts. We'll check the first section. So we'll put in the value of 30 microfarad, and then we'll enter 500 volts. You notice the little red light flashing, telling me that I can get the heck knocked out of me if I do this, if I try to measure this myself. And that will be in the half moon section, which should be this one. Alright, capacitor is ready to test. So we'll do out of circuit test, component value, reading 44.1 microfarad. When it reads high like that, that usually is an indication of leakage. See what the ESR is. It says 0.43, 0.41 ESR. Dielectric absorption. %. In other words, how much of this thing is actually trying to act like a battery. Let's do the leakage test. Here we go. Greater than 20 milliamps, less than 25,000 ohms. I'll tell you right now, it's a bad cap. See it telling me that, hey, it ain't no point in it. It's a bad capacitor. Extremely leaky. Well, let's move on. Let's do a 30 microfarad at 450 volts. So that will be the next one. And that will be the square. So let's set this up for 450 volts. Same value. Square, where's the square? Can't hardly see this stuff. Getting harder and harder. Harder and harder for me to see this stuff. Oh, it's just a big square right there. Alright, let's do it again. Want to press capacitor value. This one's showing 36.5. Kind of believe that. It says it's good. Let's see what the dielectric absorption is. It doesn't like that neither. See what the leakage says. Greater than 20 milliamps. We didn't like that one either. The next section is going to be 350 volts. Alright, so that's going to be the guess I did this wrong, boys and girls. I can't hardly read this stupid thing. 30 at 450 should have been square. It's this one actually. Let's try again. 44 microfarad. 0.67. I'm skipping the dielectric absorption. Still greater than 20 milliamps. Sorry, we're going to switch over here to this bad boy. Zoom it out a little bit. We're going to retest using the old-fashioned Heathkit Capacitor Tester. Let's see, what is the model number? This is C3, Charlie 3. 30 microfarad at 500 volts, which is the half moon. So, first things first. It doesn't show anything. It's actually telling me it's open. That's odd. Very odd. Something's wrong. You see that? Doofus. No wonder something's wrong. I've been using the wrong leads, boy, I'm telling you. Sometimes my genius just astounds me. Try this again, 30 at 500. Here we go. It's showing me around 50. What you want to do with these, if you can see that eye, what you want to do is you kind of get your reading first on these, You use your power factor for large capacitors and adjust your power factor for maximum spread of the eye. Now you've got it dialed in. So it's telling me on the 50 scale, it's telling me 50 microfarad. Okay, well, let's do the test. And so far it liked that. We're up to 150 and the eye's taking a long time to close. 250. Make sure I'm on the right one here. Tell you, my vision is just getting so pitiful. Everything about me. That's the triangle. That is the half moon. Be nice if I had a working flashlight. Anyway, the half moon is a 500 and it's supposed to be, and the leakage, it's a leaky cap. So this capacitor is bad. Extremely leaky, just like I've said in the first video. I ain't bother going to test the rest of them. So, yeah, I was trying to measure the capacitance with that Heathkit and not getting any reading at all, and I was using the stupid leads on the Syncor. Amaze myself. So here we are. I'm not going to pull the other one out. I'm going to see if I can get the values off of it. But as it stands now, there are some resistors I measured on those boards are out of tolerance. Where'd it go? On the amplifier board itself, had this little 90 microfarad, keep doing that, 90 microfarad 3-volt capacitor, which is the cathode bypass capacitor in the input amplifier tube. Anyway, it was completely open. Yeah, I haven't checked the 2.02s yet on these boards. It's a ceramic. I just can't believe that those would have a problem, so I'm not going to bother with them. These 0.1 at 200s that's in here, let me show you. I'm just replacing those on general principle. I haven't checked the resistors on this board, and I'm sure some of these are out of tolerance too. So as it stands now with this amplifier, luckily the power transformer was good. All of the tubes checked good. I haven't checked this 12AX7 yet. So we need a handful of resistors, need a handful of just, actual lead capacitors. All the filters, so we're going to say we need 1, 2, 3, 4, we need 8 electrolytics with the filters, and yes, I'm going to restuff these capacitors. Why? Because I like doing it and it looks better when you're done. The main reasons. Now this capacitor, like I said a while ago, built different, but the internals has got to be the same way and they got to come apart the same way, so I don't think I'm going to have a problem with it. So I just got to find an audio output transformer. I can find an audio output transformer, then I'll proceed with ordering all the other parts and see if I can make this thing work. There again, the issue with I mean, this is the function switch right here. Or, you know, all of that is just heavily tarnished. But I got some Tarnex that I'm going to put on here, and really you just need an artist brush. Brush that Tarnex on there and brush it to get it. You can get all that crap off of there, but you have to wash it good. So that's probably be the first thing that I do, is use the Tarnex on this switch and clean all those connections. And then I will rinse it off, and then I'll ultrasonic the board. And that'll completely clean this thing. I'm not worried about the ultrasonic damaging this switch, the wafer switch. The wafer switch, if you just get water on a wafer switch, it doesn't hurt it as long as you don't use it until it dries. But you don't spray it with something that lubricates, as far as like deoxit D5 that's got the lubrication in it, or tuner cleaner or anything. You don't put anything like that on this on these type switches, because a lot of times it will soak into these switches and make it warp. So you be very careful. You don't need to lubricate, as far as I'm concerned. You don't need to lubricate these switches. All that does is attract dirt, and when it attracts dirt, it causes, you know, connection problems, and also extreme, you know, wear. So with all that being said, it's not going to hurt this thing to be ultrasonicked. Of course, I'll pull the tube out. Matter of fact, I'm fixing to pull the tube out in a minute and see what this, see what tube's in here. See if I can get it out without breaking the board in half. Just rock it back and forth. Tube is excised. So really, all we really did on this is we didn't really fix a damn thing, but it is a continuation of the repair process. I have decided, as you already heard me say, that I'm going to try to repair this thing. It is 12AX7. $3,000 tube right here, guys. Yeah, $3,000. You know how much 12AX7s go for nowadays? Every guitar freak in the damn country, in the world, got to have them 12AX7s, man. Anyway, only made in USA, thank goodness, by Westinghouse, and it looks like Telex. I know who Telex is. No, that's not Telex. I can't read who this is. Ooh, about to drop it. Drop that $3,000 tube. Yeah, it is Telex. Telex made by Westinghouse. So there's your Westinghouse 12AX7. Boy, that thing is worth billions. Whatever. I got your 12AX7. Anyway, that's where I'm at. So I think I'm going to put all this in a project box and put it aside till I can find a transformer. So that's my status report for now. I do have the question. Like this piece of metal here, like I asked a few minutes ago, I'm just recapping. appears to be cadmium. I understand that this yellow is supposed to be the cadmium plate. Is there any way to get rid of that yellow? Is there any way to clean this to make it not look like it, you know, pollinated, or if you want to call it that? Is there a way to get rid of that? A safe way. I know I shouldn't even be touching it with my hand. I know I need to wash my hand after I'm touching this. I know not just sand this stuff or anything and get the particles in my, you know, breathe the particles. I know all that, but I don't know how to get this yellow off without it coming back. I don't know. So I have a lot of it on here. I'd appreciate a little feedback on that. Alright, I'm going to cut it loose here, pick all this stuff up, and see if I can pop a real video out real quick. So, but thanks for riding along, guys, and if anybody has any ideas where I can find a transformer for this thing, you can leave that in the comment section too. And please like and subscribe. I would appreciate it. And also, I want to take a quick moment. The last time I looked this morning, I was up to 137 or 138 subscribers. And I want to thank each and every one of you guys for that. In the last month, I've gotten a boom in subscribers, which really surprised me. If I got up to 1,000 subscribers, that would be as good to me as 100,000 subscribers is to a lot of people. There will be other things to come up if, you know, God willing, and the creeks don't rise. Other interesting projects. I may branch out and do some extracurricular stuff, like maybe a hunting trip, or, you know, or go to another one of my transmitter sites that ain't so tore up like the last one. Stuff like that. We can do some different things, because I really like making videos. I'm not the best at it, simply because I get in a rush, and I talk too damn much. So anyway, look, thank y'all for watching. Please hit the like button and subscribe. Also, thank all my subscribers that I have for joining me and riding along with me this far. I thank you guys from the bottom of my heart. And I'm going to cut y'all loose, and I'll see you down the road. Y'all take care. Bye.